For your General Physics 1 exams, you can solve most problems simply by knowing these 5 forces. First, memorize that tension is T and the elastic force is Kx. Then remember that the normal force is N, gravity acts downward, and friction opposes the direction of motion. Hello everyone and welcome to Macademy. My name is Minsikhem. For today's topic, we'll be diving into Newton's second law of motion, the law of acceleration. Now, we're all familiar with the core formula, F equals ma, right? An equation I'm sure we've all memorized automatically. What this means is that F is proportional to A. So the mass m is a constant, right? A constant. This means that force is directly proportional to acceleration. For example, if a 2-kilogram mass is subjected to a 10-Newton force, then according to F equals ma, the acceleration would be 5 meters per second squared. But here, if it becomes 20 proportionally, the acceleration becomes 10. It doubles like this. It follows this proportional law. Why this is important is because what we are learning now is Newtonian mechanics. Newtonian mechanics. Newton defined force as mass multiplied by acceleration. To put it simply, and this is the key point, Newton established the definition of force as the product of mass and acceleration. And that's exactly why it's called Newtonian mechanics. The entire field is named after him for one simple reason, because it was Newton who defined the concept of force. So the mechanics we learn is based entirely on his definition, and for that reason it's all called Newtonian mechanics. This is also the foundation of classical mechanics. Then the unit is important now, the unit. Newton suddenly defined this force, and this mechanics came into being. So what about the units? Since F equals ma, the unit for force is the unit of mass, kilograms, times the unit of acceleration, meters per second squared. This acceleration is this mass m, and F is from ma. Then you can't write it as kilogram meter per second squared like this. For example, saying 5 times 2 equals 10 kilogram meter per second squared force makes it difficult to use continuously. So what did he do? Since this was a newly defined unit, he named it after himself. The result? The Newton. He decided to name it after himself as Newton. This kilogram meter per second squared was decided to be called the unit of force, Newton. It's just his name. So 5 times 2 is 10 newtons, 2 times 10 is 20 newtons, and in this way, by defining the unit of force with his name, we first learn Newtonian mechanics. So, now that we've established this unit for force, all other types of forces must also be measured and defined in these same terms. So, we will now learn about the types of forces we will learn. Got it? What you need to memorize here is F equals ma. And Newton took his name to create a unit called Newton for kilogram meter per second squared. And because Newton defined force, we learn Newtonian mechanics, which he defined. Now let's take a look at the types of forces. All right, let's look at the types of forces. First up, we have tension. Tension is simply the force exerted by a rope. So it's called tension. Since this is tension, if you convert it to force, you pull this m with T, so tension is represented as T. Students should know that the force of tension is represented as T. Got it. Unlike other forces, tension, T, isn't calculated from a specific formula at this stage. For now, just treat it as T, Okay? So, when a force is labeled T, you'll know it stands for tension. Next up is the elastic force. This is the force exerted by objects like springs, basically anything that possesses elastic energy. How do we represent elastic force? If there is an M, let's say it pulls this way, then how is it represented? It is represented as Kx. Kx. This relationship was discovered by Robert Hooke. You've probably seen the formula F equals Kx back in high school, right? You should know the formula F equals Kx, got it? So Kx represents the elastic force. Later on, when we draw free body diagrams, you'll represent the force from a spring simply as Kx. Got it? All right, our third force is the normal force. In simple terms, it's the support force that a surface, like the ground, exerts on an object to hold it up. So if the mass is 100 kilograms, right? 100 kilograms. Then, due to gravitational acceleration, let's say it presses with 1,000 newtons. We represent the normal force with the letter N. The N actually stands for normal, which in physics means perpendicular to the surface. That's why we use N. So the normal force is denoted as N. The magnitude is equal to the magnitude of the force applied. For example, if I press down with my palm and the total downward force from my hand combined with the object's weight is 5,000 newtons, then the normal force will act in the opposite direction with an equal 5,000 newtons. Got it? So you can think of the normal force as the ground's reaction force. For every action, the object pushing down, the magnitude of the reaction is the same. Makes sense? Since it is a supporting force that acts in reaction, the magnitude is the same. Got it? Next up is gravity. This is the attractive force that exists between any two objects that have mass. For the purposes of this course, we're mostly going to focus on the specific case of the force that the Earth exerts on an object. Now, universal gravitation is a very big topic, and we will dedicate a whole chapter to it later on, so we'll save the deeper details for then, all right? The Earth's gravity is part of Newton's law of universal gravitation, which is a very important principle that states that all objects with mass attract each other with a mutually attractive force. The force that the Earth exerts is called gravity, and if there is an object like this, an object M, the force F acts in the direction of the Earth's center with a force of mg. Understood? So later when we draw free body diagrams, what's particularly important is that this object, gravity, is not visible. It's an invisible force. It's an invisible force. Gravity is an invisible force that you must always account for. So whenever you see an object, your first thought should be to identify the gravitational force acting on it. Similarly, frictional force is the same, frictional force too. When an object moves with velocity v, the ground produces a force that resists the motion. This is called the friction force. We use a lowercase f for it because it's typically a smaller force, unlike general forces that use a capital F. So friction is, well, the force that acts opposite to the direction of motion, resisting it. Resisting force. So the frictional force acting in this direction, if it moves in this direction, then the frictional force acts like this. Got it? It's a resisting force. You need to know this. And the frictional force is currently expressed in a formula. The formula for this is μn. In this formula, this tells us that the harder an object is pressed against a surface, the larger the normal force becomes, which in turn makes the friction force stronger. Now, more specifically, this constant mu is what we call the coefficient of friction. Since this is a constant, it is given. It is provided in exam questions so you can use it when it is given. The coefficient of friction varies depending on the condition of the ground. If the ground is bumpy or somewhat rough, the coefficient of friction is high. But now there are places with low friction, like water or ice. Because it varies depending on the surface, it is given as a constant, so when it is provided in the exam, you can use it to calculate the frictional force. Got it? Now, there are many forces like electromagnetic force, among others. But the reason I'm introducing only 5 here is that for the first semester of general physics, that is, until the midterm and final exams, you can solve everything with just these 5. Got it? So, it would be good to definitely know these 5. And the best way to master these forces isn't by rote memorization. It's about building an intuition for them. You'll get comfortable naturally by practicing with free body diagrams, and trust me, we'll be doing that a lot, okay? Next, the vertical support force is called the normal force, denoted as N, which is the force supporting in this direction. Then, gravity is an invisible force directed towards the center of the Earth. Next, frictional force is opposite to the direction of motion. If the motion is in this direction, then the frictional force is in that direction.